Hello friends, in the last lecture we have discussed definition of partial differential equation, then what is its order, degree, and what are the basic types of ordinary differential equations, partial differential equations of first order and first degree. Now in today's lecture see the formation or what we call it as the origin of partial differential equations. So under it, we shall now examine the interesting question of how partial differential equations arise. We show that such equations can be formed by elimination of arbitrary constants or arbitrary functions. So friends, here you remember one thing in your mind. We can form a partial differential equation by the elimination of arbitrary constant or by the elimination of arbitrary functions. So before here it, see the derivation of partial differential equation by elimination of arbitrary constants. And in today's lecture, we will discuss the examples which are based on it. So generally here, a differential equation, a partial differential equation, we can write in this form. Consider an equation f of x, y, z, a, b equal to 0. Here a and b, these are nothing but arbitrary constants. Let z be regarded as a function of two independent variables x and y. X and y. Here z is a dependent variable, x and y are independent variables, and a and b, these are arbitrary constants. So differentiating this one with respect to x and y partially, we get. So if we differentiate this one with respect to x and y, partially we get da by x plus, actually there you will get da by z into da by z by x. Actually, we want here the derivative of here this partially with respect to x. While differentiating partially with respect to x, you remember y, a and b are constant. Means capital F becomes a function of x and z. And its derivative partially with respect to x, you will get da by x plus there you will get da by z into derivative of z with respect to x, that is da by z by x, that is p, and is nothing but equal to, you will get 0, means that derivative you will get like this one, da by x plus da by z into da by x, that is p, equal to 0. And in similar way, while differentiating equation 1 partially with respect to y, x, a, b are constant. So in that case, capital F becomes a function of small y and z. And its derivative partially with respect to small y, you will get da by small y plus da by z into da by small y. Da by small y is q. This you will get here this equation. So eliminating two arbitrary constants a and from a and b from three equations of 1 and 2, from three equations 1 and 2, we obtain an equation of the form f of x, y, z, pq equal to 0. Means if you observe here this equation and equation 1, means from these two equations you determine the values of here, we have eliminated here a and b from it. So put these values of p and q there in equation 1. It gives here, or eliminating a and b, you will get here p equal to a. From this you will get p equal to a. From this you will get q equal to b. Means you replace a by p, b by q, and it gives here what we call it as the partial differential equation of first order. Now, what is situation 1? Situation 1 means when the number of arbitrary constants is less than number of independent variables. You remember here this statement because maybe this statement is there in the examination for multiple choice. When the number of arbitrary constants is less than the number of independent variables, then the elimination of arbitrary constants usually gives rise to more than one partial differential equation of order 1. Means here number of arbitrary constant is only a here. If you consider this example, number of arbitrary constants here in the equation is a only, and that is less than the total number of independent variables. Independent variables are x and y, dependent is z. So this a is only one arbitrary constant, and independent variables are two. means the arbitrary constants are less than the total number of independent variables. In that case, it gives more than two, more than one. It rises to more than one partial differential equation of order 1. So for example, if you consider this equation, partial differential equation, then here a is an arbitrary constant and x and y are two independent variables. So differentiating these four partially with respect to x, we get delta z by delta x equal to, it gives a. And if we differentiate this partially with respect to y, it gives delta z by delta y equal to, it gives it to be 1. Means it gives here two, uh, eliminating a from 4 and 5, we get this as a required equation. But we have obtained here, this is also a partial differential equation, q equal to 1. So this is also a partial differential equation. Since 6 does not contain arbitrary constant, so 6 is also partial differential equation. Means thus we get the two partial differential equations. By the elimination of a from 4 and 5, you will get here this as one partial differential equation, and this is free from arbitrary constant, so this is another partial differential equation. Thus we get two partial differential equations of order 1. What is the second situation? If the number of arbitrary constant is equal to total number of independent variables, then in that case it gives unique partial differential equation. If the number of arbitrary constants is the same as the total number of independent variables involved in the given equation, then elimination of arbitrary constants shall give rise a unique partial differential equation. So what is given question, you see, eliminate a and b from this. So a and b are arbitrary constants and x and y are independent variables. So if you have eliminated a and b, to eliminate a and b, you differentiate this partially with respect to x, then differentiate this partially with respect to y, and you eliminate a and b. So what it gives, you see, differentiating given equation partially with respect to x, we get what it gives. A into derivative of z with respect to x is delta z by delta x equal to b and y are constant. A is also constant, so there you will get a square into derivative of x with respect to x is 1. So it gives what? Similarly, differentiating given equation partially with respect to y, we get, means if we differentiate this equation partially with respect to y, it gives a into delta z by delta y equal to, it gives it to be 1. And from it, you will get a equal to 1 upon q. You substitute here that one value of a here. So what it gives, you see. Next, eliminating a from 1 and 2, we have what it gives, delta z by delta x into delta z by delta y equal to 1, and which is a unique partial differential equation of order 1. So eliminate a from 1 and 2, a from this 1 and 2. If you have eliminated a from this 1 and 2, it gives here unique partial differential equation. And what is it? It gives, means here put the value of a as 1 upon q here, or a as 1 upon delta z by delta y here. It gives here, or here a gets cancelled. Delta z by delta x equal to, you will get it to be a, and you put their value of a as 1 upon delta z by delta y, and take the cross multiplication. It gives here what we call it as a the partial differential equation to be like this one, delta z by delta x into delta z by delta y equal to 1, and which gives a unique partial differential equation of order 1. What is third situation? When the number of arbitrary constants is greater than number of independent variables. Number of arbitrary constants is greater than number of independent variables, then elimination of arbitrary constant leads a partial differential equation of order usually greater than 1. Means number of arbitrary constants is greater than the total number of independent variables. So generally in partial differential equation, we have only one dependent variable and two independent variables. So if arbitrary constants are more than 2, then in that case, it gives a partial differential equation of higher order, that is order greater than 1. So here given equation is this one, we have considered as it is. Differentiating this one partially with respect to x, it gives delta z by delta x equal to a plus X is also present here, so there we get Cy. Similarly, differentiating one partially with respect to y, we get dava z by dava y equal to b plus cx. So these two equations we have obtained. So although we have not eliminated a and b, so what it gives? From 2 and 3 we have. If we differentiate 2 again with respect to x, it gives dava square z by dava x square equal to 0. And if we differentiate 3 again with respect to y, it gives dava 2 by dava 2 z by dava y square equal to 0. And if we differentiate here dava z by dava y with respect to x, it gives it to be c. So from 2 and 3 we get what? X into dava z by dava x equal to ax plus cxy, ax plus cxy, and y into dava z by dava y equal to by plus cxy. And what you have to do, you take the addition of these two. So here ax plus by plus it gives ax plus by plus in my sense here, see uh, x into dava z by dava x plus y into dava z by dava y equal to z plus xy into dava 2 z by dava x dava y. So dava 2 z by dava x dava y, here uh, ax plus by plus c into xy is nothing but z. Ax plus by plus c into xy is z. So you substitute here values of here these first three terms as z plus xy into L of c, you will get it to be this one. And that you have to substitute here. So what it gives, if you observe here the order of this is a partial differential equation which we have obtained by eliminating the arbitrary constants a, b, and c. So what is the order of this equation? Order is 2. Means if here the total number of arbitrary constants is greater than the total number of independent variables involved in the given partial differential equation, then it gives the higher order partial differential equation. Thus, we get two partial differential equations given in 4 and 6. Given in this 4, and here this equation is our equation number 6, which are all of order 2. Means these two equations and here this equation, means in all totally we have obtained here three equations. So uh, these equations whose order is greater than 1, means we have obtained here three equations whose order is 2. So what note is written here, the equation 3 from a and b will be required partial differential equation. The equation free from A and B, free from A and B means this is free from A and B, this is free from A and B, or this is free from arbitrary constants. Then in that case, that equation is also a partial differential equation. Now, next is here few examples I have taken. Find a partial differential equation by elimination of A and B from this given relation. But friends, we will discuss here this part in the next lecture. So today we'll stop here. So what part we have studied today? Basically, we can form a partial differential equation by two different ways. What is one? By the elimination of arbitrary constants, and what is second? By the elimination of arbitrary functions. So today we have discussed how to form a partial differential equation by the elimination of arbitrary constants. So under it we have studied in all totally here three cases. What is first case we have studied? We have studied here the first case as what? If the total number of arbitrary constants is less than the total number of independent variables, then in that case it gives here more than one uh, partial differential equations of order 1. Next, if the second case we have studied, if the total number of arbitrary constants is equal to the total number of what we call it as a independent variables present in the given equation, then in that case it gives unique partial differential equation of order 1. And next, if here the total number of arbitrary constant is greater than the total number of independent variables, then in that case it gives here the partial differential equations of higher order. And maybe you will get it can't gives here unique, but it gives more than one partial differential equations of higher order, is order higher than 1. In the next lecture, we will discuss here again few examples how to form a partial differential equation by the elimination of arbitrary constants, and then we will proceed towards the next article, that is nothing but how to form a partial differential equation by the elimination of arbitrary functions. So today we'll stop here. Have a good day, friends.